Alright, I'm here. Alright, let's get on to this. I want to give you some of the overview ideas here on the properties of common minerals page of your science reference tables. It's the back cover, page 16. If you haven't looked so far, just flip it right over. Alright, we're going to go over the characteristics and these common properties that you can use to identify any mineral. And in fact, just by knowing these characteristics, you can identify any mineral. It doesn't have to be a mineral on this list, but these are distinct characteristics. And which ones am I talking about? I'm talking about luster, hardness, cleavage, and fracture. These are the four most common that you're going to use right here. Other characteristics, other properties are common colors, and sometimes they're listed here under this distinguishing characteristics. Now, every single one of these properties is due to one thing, the internal arrangement of atoms. So if you find that on a test, please select that answer, because that is the reason for the luster, the hardness, the cleavage, the fracture, the colors. The other characteristics of this mineral are due to that. The difference between diamond and graphite is the internal arrangement of atoms. They're both made of carbon. Graphite, you waste every day on paper. Writing, scribbling it down, throwing it right out. Diamonds, different internal arrangement, different structure, different properties. Alright, so let's get into some of this stuff. What do we see here? On the very top, we've already talked about the top four here in blue. We've got common colors, distinguishing characteristics, uses, the composition, and the mineral name over here. Now each one of these characteristics below is identified, and this corresponds to the mineral name on the right hand side. So everything along this is all graphite. And everyone here is a hematite characteristic. The characteristics are similar, you'll notice for some of them, but the differences is what will help you identify them. Now, when we look down in luster, there's two choices, yet one of two. It's either metallic or not metallic. That's it. Those are your two choices. But then hematite can be either. Alright, hardness. Mohs hardness scale goes from 1 to 10. 1 is graphite. Good example. Baby powder, talcum powder is a 1. Very soft. Very hard, diamonds. Diamonds are really high in the scale. So as you go down the chart, we have a higher hardness. And it's not really a hard, like you would think as far as durability. It's more of a scratchability. So it should really be called scratchability, not hardness. Alright, now, what else can we look at here? Cleavage or fracture, whether it's been cleaved, like a butcher's cleaver has made a very flat edge when it breaks, or maybe it's been fractured. The line here will distinguish whether it's one or the other. So for magnetite, we look over here, it is fractured. Graphite and galena are cleaved. Alright, composition. We got a little star down here, so let's go down to the bottom. Chemical compositions. We've got the chemical composition of the minerals. So if we take quartz as an example, SiO2. So this would mean that it has Si, silicon, and oxygen. So we've got O for oxygen. What else do we have? We've got Na for sodium. We've got S for sulfur. We've got Ti for titanium. We've got Mg for magnesium. So it always starts out with a capital letter to begin with and the lowercase letter secondly. So we can tell the difference between whether this is the start of a new element or not. Does anyone know any mineral jokes? Nah. Alright, well I think that should end it. And if you need any more help, just please let me know.